So let us start with a simple discriminant analysis for classifier. For that, I thought I'll just show you a simple PDF what I'm going to do. So what I'm going to do is, if you have different classes, you need to assign it, isn't it? So it's very, very important application as far as image processing is concerned till now. So if you have different classes, you need to assign to your particular class. For example, here the standard example they'll take is iris. Okay, so it's a family of flower. You, as you know, it's going to have different features. For flowers, I'm just going to take this petal length and sepal length and width as feature. Similarly, you can take any feature as per your application. So the first thing you need to do in any classification problem is extract the important features specific to that image and train your classifier so that it will learn that feature. And it's just like we are teaching our kids, isn't it? So they don't know what is a flower basically and what is the difference between a lotus or lily. So you'll be teaching, if it is looking this way, it's lotus. If it is looking this way, if the color is this, if the shape is this, it's lily. In the same way, we are going to train the machine. If the petal length and width is this way, sepal length and width is this way, it belongs to this family of flower. Okay, this is what your machine learning basics is going to be. And for that only, we are having so many applications like deep neural network. Tremendous applications are going in that area. So here I have taken a simple classifier in which it's going to take petal length and sepal length and width from different iris flowers. We have taken just from 3 different species, and we are going to take 4 features: petal length and width and sepal length and width. Okay, so given the measurement of this feature, we are just going to predict to which species it belongs to. We are just going to classify whether it is iris setosa or iris virginica or iris, one more class of iris. Okay, so in this way, this is what I'm going to do using MATLAB. I'm just, if it is this way, if it is projected in this space, it belongs to iris setosa. If it is coming here, see here, all the flowers having common features, it will be mapped to a particular place in feature space. So all the flowers which is marked in green, which is having same kind of petal width and length, it's coming in this space. Similarly, this blue, it belongs to virginica. See, this is common for any classification you take. If you want to classify between a lion and a tiger, you know what all the characteristics of lion, you know what all the characteristics of tiger as human. That's what we are going to do for the machine. The machine has to learn and it has to classify on its own. For that only we are doing. Okay. So we'll take a simple example for this, which will do linear as well as quadratic discriminant analysis. So I'm just loading the standard data which is present in the MATLAB, which is Fisher iris. Okay, I'm just loading the sample data, and then as I told you, I'm just going to take, see, if you load the data, it will be stored in Excel format. You'll be having different features present. I'm just taking 2 features, which is my petal length and petal width measurement alone I'm taking, and I'm seeing how the data is getting classified. Here I'm not at all taking the image. I'm just taking the data classifier using linear analysis. So I'm taking the 3rd and 4th measurement, so that only I'm putting 3 and 4. I'm plotting the data using scatter plot again. Okay, and I'm just going to classify it whether it is setosa, versicolor or virginica. See here. So this class, it belongs to setosa. This is your versicolor and this is your virginica. And I'm using different legends for different classes. Hope you are getting this. If the petal width and length, or because as you know, for a family of flower, all the features are going to be more or less same. Yeah. So it's getting scattered here. And this is very, very important feature. The very important thing in feature extraction is you need to extract the important feature For example, if you take some example like apple and orange, if you take just the shape, both are round, so that is not a feature. If you take color, more or less it's going to be different only, but for some fruit the color may also be same, so you go for some other thing. In that way you can mark the important feature, whatever it will be differentiated easily, and then you can classify it easily. So here this one feature, it's classifying this three categories, but it may not be suitable for all the different classes. So it's classifying, like by using this, I can easily draw a line which will differentiate between setosa and versicolor. But using a linear discriminant analysis, it's difficult for me to exactly classify virginica and versicolor because it's closer to each other. So I need to go for some quadratic function in that case. Okay. So I'm just like fitting a linear classifier by using fit C discrete function